Hey, what's up, guys? This marks the start of Jargons Explained, my new series here in YouTube by Primal Thinker. So, today we're going to talk about epigenetics, and we will answer the question why you cannot grow a tooth on your eyeballs.
Hi, Jonah of Primal Thinker here, and I want to have a little disclaimer here that I'm not a doctor of any sorts. I'm just a girl in the internet trying to connect the dots, sharing my own experiences with you. And if you're okay with that, please hit the subscribe button and the notification bell so I can share my Eureka moments with you.
Okay, let's dive in. So, first, to discuss what epigenetics is, we have to know what genetics is first. And genetics, when people hear about genetics, it's automatic that we think about DNA, right? And DNA is passed on to us by our parents. So, for example, if you have this search for your long lost parents, today you can verify if someone who claims to be your parent is the real one by having a DNA test. Because most probably you will have, no, not most probably, you will have 99% similar DNA with your father or mother. Okay? So that's the rough overview of genetics. Now, next question is what is epigenetics? Let's start with this mystery that I'm about to present to you. Well, your body consists of trillions of cells, and for every organ, you have uh, a cell, right? So for your eyeballs, you have an eyeball cell. For your skin, you have a skin cell. And every cell in your body has the same DNA. But why is it that different cells in your body have different appearances or different comes in different sizes, comes with different characteristics? Your skin is not an eyeball, your eyeball is not a skin. So we will solve that mystery as we go along. But for now, to explain that, let me show you an analogy here. You can think of genetics or your DNA, for example, as a blueprint for your house. So, what does a blueprint has? It has the instruction on how to make your living room, your bedroom, your roof, your terrace, everything about your house, right? But the blueprint cannot build a house, right? It's just the instructions. To be able to build the house, you need an executor, like carpenters. Oops, like carpenters, um, who will do the job for you, who will build the house for you by following what's in your blueprint. Another analogy, if you like to cook, you saw it. It's a recipe book, a cookbook. A recipe book has different recipes for different kinds of dishes. But the recipe book does not decide what you will have for dinner, right? It's the cook, or you, if you're the one cooking, who decides which one in the recipe book you will execute. Which recipe will you use for dinner, right? And if you are, another analogy, if you're a software engineer like me, uh, you can think of genetics as hardware, okay? And the hardware is useless unless there is someone who will execute what's to be done with the hardware, right? So it's like genetics is the hardware, epigenetics is the software. Epigenetics actually means epi means above genetics. It's kind of we are modifying on top of the genetics. So, to answer this question of mystery about the eyeball cell and the skin cell, why do they have different um, properties when in fact they have the same DNA? Here is when epigenetics come to play. An eyeball cell, uh, the same DNA with your skin cell, but it has different tags. And these tags are telling the cell which genes to turn on and which genes to turn off. So, for example, for the eyeball cell, the gene to make an eyeball is turned on, and the gene to make a skin cell is turned off. That's why you cannot grow a skin on your eyeballs. And same goes with your skin cell. For the skin cell, it's the other way around. You cannot grow an eyeball on your skin. That will be hilarious and freaky. And so for the skin cell, same DNA, but the gene for making skin is expressed and the gene for making an eyeball is turned off. So this is just to give you an idea. But there are hundreds and thousands of genes in your body. So there could be a gene for being happy or sad, or there could be a gene for being fat or skinny. It could go on and on. There are thousands of genes. But one question you might have is how about um, identical twins, where they have the same set of DNA, 100% the same? And how how does epigenetics come into play with twins? To explain that, look at this two mouse or mice. And these two mice, would you believe that they are identical twins? So what scientists did here is they just flipped some genetic switches that created differences in size, fur color, and health. So as you can see, epigenetics really comes a long way when um, uh, and it affects even your size, fur color, and health for this matter. And so that's why if you know twins, you might know identical twins who have very different traits. You might like the other one more than the other. One might be more adventurous, one might be more shy, and it's because of epigenetics. And let's go to real life example. Well, this is I just remember this from the book of Weston Price from Nutrition and Physical Degeneration. They are identical twins. And note that they look very different. The younger one at the left has a narrowed face as compared to the one on the right, which is more handsome. So you can say that the more handsome gene was expressed more on the guy on the right rather than the guy on the left. And also the genes of having excellent teeth, as you can see. So this shows that even twins with 100% the same DNA can end up uh, being different because of epigenetics. With that in mind, you might have this question. Okay, so epigenetics has an effect on us, but how do we affect epigenetics? This is when the nature versus nurture debate comes to an end. Well, nature, we can think of nature as the genetics or the DNA part because we cannot change our DNA, right? That's nature. It's like our destiny versus nurture, which is epigenetics. And this we have control. We have control on which genes to express, which genes to turn on and turn off. And to answer the mystery between these twins, the guy on the left uses modern food. Modern food, modern diet that means sugar, processed foods, canned goods, refined grains. And the guy on the right uses native food. And look at the big difference it has on their facial structure. So the idea here is that epigenetics is greatly affected by your lifestyle, your environment, um, how you respond to things, how you react. Basically, everything in the outside environment is affecting you. What you put into your body, how you use your body, everything has an effect on epigenetics. Okay, so given that, the next question that may pop up in your mind is, can epigenetics be inherited? Because we know that genetics or the DNA is handed to us by our parents. Now the question is, how about epigenetics? What I mean by this question is, for example, your mom, or let's say some mom, has the gene expression for being fearful turned on. This is a fearful mom, and the happy gene is turned off. So this mom is not happy. Can that um, epigenetic expression be passed on to her child? Now, I'll answer that in a minute, but in order to explain it better, let's look at this experiment by the scientists to explore this field. So, what they did is they have a mouse and subjected the mouse to the smell of cherry blossom, and right after the cherry blossom smell, uh, they shocked the mouse. And of course, the shock developed fear in the mouse, and they kept on repeating this shocking cherry blossoms shocking until such time that the mouse has associated the cherry blossoms with being shocked. So now every time the mouse is subjected to the smell of the cherry blossom, automatically the mouse is being fearful. And guess what happened to the offspring of this mouse? So the offspring obviously was not subjected to the shock. But once the offspring or the kid mouse, let's call it the kid mouse, was subjected to cherry blossom smell, that kid mouse developed fear as well. So that's the long answer, and the short answer is yes. And to convince you further enough, this is from real life scenario. Again, from Weston Price's book, Nutrition and Physical Degeneration. You should read it. This is a father in the primitive coastal Indian of Peru. As you can see, this father has a great facial structure and a nice dental arch. However, when this father had subjected himself to the modern food, which is sugar, processed foods, refined grains, canned goods, everything modernized, uh, who suffered after that? Because once he had subjected himself to the modern food, he has turned on and off some genes, some genetic expressions, and that was passed on to his offspring here on the right. And the son at the right presents distortions of both facial and dental arch form. As you can see, he has bad teeth. So that tells a lot because um, the question is which, I want to leave you with this question. Which genes are you turning on and off? Because if we think about it, you have a control on which genes to turn on and off. You want to be healthy, then eat healthy and um, exercise, work out, sleep, have a quality sleep. Uh, and these are all factors affecting our epigenetics, our lifestyle, our environment, and another motivation to live as a better human being is that if you are planning to have an offspring, keep in mind that the way you live your life will either be a burden or it will make your child's life easier. I mean, do you want your child to inherit your being unhappy or unfulfilled human being? We don't want that. So I'll leave you with that. That's something to reflect on. And I hope this has empowered you that you can change your genes, your epigenetics. You can change your life. Thanks for watching.
Thanks for watching, guys. I have just one request from you. Please do hit the like button and subscribe if you are enjoying my videos, because that is the only way that I know that you are enjoying my videos. So that keeps me inspired to create new videos for you. So see you in the next video.